In this video, you will learn how to solve some problems that involve the conversion of the number of moles to number of grams, or number of moles to number of moles. All right, let's solve this problem here. How many moles of aluminum, or Al, are necessary to form 83.0 grams of AlB3? AlBr3 rather, or aluminum bromide, from this reaction. So we're given this reaction here. You have to check first if the chemical equation or reaction is balanced. So we have 2 aluminum here on the reactant side, 2 aluminums and 2 aluminums on the product side, and then 6 bromine and 6 bromine. So the reaction or the equation is balanced. So we're given here 83.0 grams of aluminum bromide, and then we need to get the number of moles of aluminum. So we start with the given. So that would be 83.0 grams of aluminum bromide. All right. We divide this by its molar mass. So the molar mass of aluminum bromide is equivalent to 266.69 grams per mole. So we just have to multiply this by 1 mole of aluminum bromide is to 266.69 grams aluminum bromide. And then the grams here cancel out. Then we multiply this by the mole ratio of aluminum and aluminum bromide. So from the reaction, we have 2 moles of aluminum and then 2 moles of aluminum bromide. So that would be 2 moles aluminum is to 2 moles of aluminum bromide. So the moles aluminum bromide here cancel out. Okay, this cancel out. And then we are left with moles aluminum. So our answer would be moles aluminum. Okay, we just have to multiply 83 times 2 divided by 266.9 divided by 2. Okay, let's calculate that. Now we get 0.311 moles aluminum. So this is our answer here. All right, let's solve another problem. How many moles NH3 or ammonia can be produced from 3.06 moles of nitrogen in the following reaction? So we're given this reaction here. On the reactant side, we have a nitrogen gas plus hydrogen gas. It produces, or they produce, ammonia or NH3 gas. So our nitrogen is balanced, our hydrogen is balanced. So the chemical equation or chemical reaction is balanced. Now we solve this problem. We start from the given value here, which is 3.06 moles nitrogen. And then we are asked for the number of moles of ammonia. All we have to do is we multiply this by the mole ratio of nitrogen and ammonia. So that would be 2 moles NH3 is to 1 mole nitrogen. And then the mole nitrogen here cancels out. Then we're left with moles ammonia or NH3. So that would be 3.06 times 2, and we have 6.12 moles of NH3. Alright, let's solve another one. How many moles of ammonia would be required to react exactly with 0.806 mole of copper 2 oxide in the following chemical reaction? So we're given this chemical reaction here, 2 ammonia and 3 copper oxide. Okay, let's check if this is balanced. 2 nitrogen, 6 hydrogen, 3 coppers, and then 3 oxygen. Okay, the equation is balanced, and now we can solve the problem. All right. So we're given here 0.806 mole of copper oxide. We start from there, and then we need to solve for the number of moles of NH3 ammonia. So it would be 0.806 moles or mole of copper oxide. Then we multiply this by the mole ratio. That would be 2 moles NH3 and then 3 moles copper oxide. And then the number of moles or the mole unit cancels out. Then we are left with moles NH3. The mole unit of copper oxide cancels out. So we have 0.806 times 2 divided by 3. Okay, and that would give us 0.537 mole ammonia.